Hello and welcome to the Reapers. So we've got a little educational video for you. We've been putting it off for ages, but we've just got to get it done, and it still confuses me. You've probably known Cap for a long time now, and you know I'm not the sharpest tool in the shed, so I'm the layman here, and we've got some smart guys that are going to help me explain it. But just to give you a rough idea of what we're talking about, when we talk about speed in an aircraft, it's not simple, it's complicated. Speed in a car is simple. It's just essentially it moves in two dimensions, you know, X and Y, and it only has one type of measurement. It doesn't really have a name. It's just called speed, and it can be measured in either miles per hour or kilometers an hour. I suppose that's how you would sum up a car. Pretty damn easy. There's nothing else to think about. When it comes to an aeroplane, it's much more complicated because it also moves up in a third axis, i.e. the z-axis, and it also moves up through the atmosphere, and the atmosphere, as you get higher, as you know, obviously gets thinner and less pressure, and then you have to start taking different types of speed measurements. Each of those speed measurements can be described in knots or miles per hour or kilometers an hour, so we've got a huge amount of measurements to bounce around, and it's important that all of the Grim Reapers flyers, and really the fans as well, because viewers have to know these speeds to understand what we're doing. Understand it to know what's going on, because it is critically important. And just to show you how complicated it is, I still get confused all the time, and I pretty much do this all day. So we'll start off with indicated airspeed, what it is, how it's calculated, and the most important thing, why it's there. So indicated airspeed, I'll unleash blood in a minute, but my understanding of indicated airspeed is that it's so you can fly your aircraft, okay? So it's nothing to do with like knowing how fast you're going over the ground or how soon you'll get to Milan or Rome or whatever. It's purely to keep your aircraft in the air. Indicated airspeed has absolutely no relation to how fast the aircraft is flying above the ground. So let's take it to the extreme. It's the easiest way to understand it. If you've got an SR-71 Blackbird that's flying 300 knots at sea level, so very low, then it's also roughly, because of just how indicated airspeed works, it's roughly flying about 300 knots above the ground as well. Okay, that makes sense. Knots, just so you know, is just another measurement of speed, like miles per hour, like kilometers an hour. It's just a measurement of speed. It's just what we use in aviation. Now, that Blackbird can climb to 90,000 feet, which is really high, like right to the top of the atmosphere, and it can travel level again at 300 knots still. So it's still going 300 knots, indicated airspeed, but it's no longer travelling along the ground, over the ground, like a car at 300 knots. It's now going over the ground at 2,000 knots. So, you just got to think about that. So it's still travelling at an indicated airspeed of 300 knots at 90,000 feet, but instead of going over the ground at 300 knots, it's moving over the ground faster than a rifle bullet at 2,000 plus knots. So that takes a while to drill into your head. It took me ages to figure that out. And why does it do that? Well, it's because it's a dedicated measurement of flying your plane, not geography or locating your aircraft. So, and it's there so that if, say, the Blackbird stalls at 150 knots at ground speed, indicated airspeed at the ground, it also stalls at 150 knots at 90,000 feet. Indicated. That's the best way I can think of explaining that.
So, just to summarize all of this, indicated airspeed is what's shown on the little steam gauge in your cockpit usually, and it's what we use for like staying near each other, staying in the same speed, and it's what your stall speed is in.
Yes, you fly on the indicator. So, in very simple terms, indicated airspeed is just how much your pitot tube, which is what you use to measure airspeed, is going to display. And to quickly explain how a pitot tube works. All it is just a tube. It's not particularly complicated, in which you're going to push air into it through the fact that the air is traveling at maybe 150 knots onto your aircraft. It'll travel 150 knots into the tube, and what you're comparing is what's known as the static pressure. So the pressure caused by the fact there's just air there, and the dynamic pressure, which is the pressure caused by the speed of the air. So if that air travels down the tube, it's going to stop at the end, you'll have some extra pressure. And that's the stagnation pressure. So that is static plus dynamic. And it's the dynamic pressure that you can use to convert to airspeed, because it's proportional to the square of velocity and density. And this is why it's useful for flying on, is because the amount of lift generated by your wings is also proportional to the air density. So as the air density changes, it's going to be accounted for by the pitot tube.
Imagine if you're driving in a car in the rain and you stick your hand out the side. So say it's a heavy rain because air is more denser the closer you are to the surface of the earth. So you stick your hand out, you collect like a bucket full of water. So that's, for example, 300 knots. If it's a light drizzle, assuming like simulating like you're higher up, you would need to basically go a lot faster to get the same amount of water in that bucket in the same amount of time.
Roger that. Understood.
Basically, up at 30,000 feet, you're still reading 300 knots because the same amount of particles, air molecules are like going into your pitot. But you need, because air is so much less dense up there, you need to be going a lot faster to get that same rate of molecules into your pitot.
Roger. Right, so we've explained indicated airspeed, and it does take you time to get your head around that, so just have a play with that. Next, we're going to move on to calibrated airspeed, and this is something that's also relevant to us in the DCS community. We'll tell you why soon, but first we're going to find out what is calibrated airspeed and why does it exist.
Calibrated airspeed is simply, it's just like IAS, but it's a bit more accurate. Because pitot tubes aren't the most accurate thing in the world, there's some errors in the measurements. Calibrated simply takes that, puts it through a computer, does some maths, and come out with a different number, which is very close, but it's a bit more accurate and true to life.
Take, for example, I believe the Typhoon has 5 pitot tubes on the front of it. And they're all going to give you slightly different answers. And all you're doing is just summing together the information it's giving you and finding out what the most likely actual airspeed you're getting is.
Yeah, just to refer to Mark's point as well, in addition to the position of where the pitot is that will sometimes have some deviance, also sometimes the instrument itself might have some error, and that is generally tried to be corrected with calibrated.
Okay, so I think Kirk really explained that really well, which is good. We explained why it was there, and now we've got to explain how it affects us in flying in DCS. So so if you have let's say an F-15, you're flying along in your F-15. And you're looking at your speed, which is shown on the head-up display on the green HUD, and it's saying say 300 knots. That's actually not telling you indicated. That's telling you calibrated. So on the HUD, on the digital HUD of an F-15, it's showing you the calibrated, or what some people will call it, corrected airspeed. Okay. Now, if you've got an F-5 Tiger flying alongside in formation with that, the F-15 will say, "Hello, I'm flying at 300 knots." The F-5 flying beside him will look at his speedo, which is a steam gauge rather than a calibrated airspeed digital, and it will read different.
Slightly
yeah,
different,
well,
yeah.
you say, I mean, yeah, we've seen 30 knots difference though, and so it's just explained something why some planes like the A-10 and the F-15 can show a different speed to other guys in the formation, and we've tried to get our head around it for ages, and this finally explains why. Simply because some planes are reading in calibrated airspeed. Yes, they also have a steam gauge of indicated airspeed, but generally you look at your HUD because it's easier. And some older planes like the F5 that have steam gauges with indicated airspeed will read slightly different. That helps me a lot in the formation.
That was a good summation, Cap. I think you got it absolutely right now.
Lovely job. Okay, well, next, we're not going to dwell on this at all. There's something called equivalent airspeed, which you can see here. Now, as we understand it, this does not affect us in the DCS community at all.
But I think we shouldn't even bother with EAS in the video, except for like mentioning that it exists, because I'll just complicate
Yeah, that's
things.
fine.
Absolutely.
So yeah, so just to say, EAS, equivalent airspeed, does exist in reality, but in DCS, for our purposes, it just is no use, so we will ignore EAS.
Yes.
Let's continue. Now we get to my favourite, and this is the one I like to use when doing my tactical debriefs. It's called true airspeed, and it's going to be a tough one to explain, real tough one. So in my understanding of true airspeed, it's how fast, it's not anything about pressures per se, but it's how fast your aeroplane is moving, actually moving through the air. So if you imagine that in this case there's no wind, the air is a static object almost, it's how fast the SR-71 is moving through the air, which is different to indicated airspeed, but that is not how physically fast the plane is flying through the air. I'm right, aren't I?
Well,
I believe true airspeed is defined as ground speed and then minus the wind.
To be a more layman explanation, basically true airspeed is how fast the aircraft is flying through the air. Indicator is how much air is hitting the aircraft.
Yeah.
Okay, so our true airspeed is so remember, our indicated airspeed is nothing at all to do with how fast that plane is flying through the air. That's weird, I know, but you've got to get that round your head. The true airspeed is essentially how fast your plane is flying through the air. I know windage does complicate that, but we're negating wind for this purpose. When I do my tactical debriefs, you can see the planes flying around, and it shows the speed, and it shows the speed measured in true airspeed. I try and always make it show true airspeed, because that is how fast that plane is actually moving in relation, essentially, to the world, but, you know, to the air. And so that's that. Most planes don't show true airspeed in their cockpits. For instance, F-15 only shows indicated and calibrated. I think a flanker can show true airspeed when you put it on BVR mode, but most planes you're only ever going to get calibrated and indicated airspeed.
Cap, on that note, I think all the radar readouts are in true airspeed.
Roger.
Like
understood. So yeah, so like what I would call the tactical things, like the radar and stuff, that becomes more of a tactical rather than flying, if it's such. So true airspeed is, yeah, right. Correct. I stand corrected. An F-15, for instance, does show its radar readouts in true airspeed, and it probably will show your true airspeed as well. Yeah, so it's true airspeed is very similar, not quite the same, but very similar to how fast you are moving over the ground, like a car. Car is effectively moving over the ground and giving a ground speed. So in fact, I believe we could say, so here's something to point out. At sea level, true airspeed, which is our biggest figures really so far, true airspeed and indicated airspeed. At ground level, or sea level I should say, sorry, true airspeed is almost the same as indicated airspeed. I know there's a slight difference there, but you know, for what we care about, they're essentially the same thing as long as the plane's flying straight.
And both of those are very similar to ground speed.
Yes, that's at sea level, yes, that's exactly correct. Now, when we move up, FL 200 means flight level 20, so that is 20,000 feet. So this is up to 20,000 feet. It changes. So the indicated airspeed is still 325 knots, but the actual true speed that the plane is flying through the air, assuming no wind, at this Angels 20 is 435 knots. So it's critical to get your head around that. Well, there's any difference. True airspeed also can be measured with the plane flying straight and level, but it's also just as true as if the plane was turning or going up or vertically up or, you know, whatever, doing maneuver. The true speed is still relevant and means the same thing with whatever vector the plane is flying on. And that leads us on to the controversial, but what I think is important one, onto ground speed. So we said true airspeed is how fast the plane is flying through the air. Ground speed is very similar to that, or it can be very similar to that, but it's slightly different. So ground speed is what you would be interested in if you were a tactical commander looking at a two-dimensional battle screen, and we do have those. Most flights we have tactical commander who just looks at, you know, dots on a radar screen, and his ground speed is simply that aircraft, how fast it's moving across the ground. So if we go back to our very first analogy with the SR-71, up at 90,000 feet, 300 knots indicated airspeed, it's moving over the ground at 2,000 knots. Okay? Now, if our plane, you guys may correct me, but if our plane in question is moving at true airspeed 435, and it's flying straight and level, and only if it's flying straight and level, and there's no wind, hence why I've done this little sum here, that's true airspeed is also the same or very similar to ground speed, isn't it?
Yes.
Okay,
yep.
So true airspeed, if we ignore wind, is always going to be effectively the same as ground speed as long as the plane's flying straight and level. If it's flying up, say vertically up, the true airspeed will still be 435, but the ground speed would be 0 because it's not moving at that point over the ground at all. So it's basically true airspeed on a straight vector, or near enough to that, ignoring windage. I couldn't find any other simpler way of explaining these lots, so...
You basically, you fly on indicated, you navigate on ground speed.
That'll do.
Exactly.
You fly on indicated, you navigate on ground. So, yeah, so I guess that's an easier way of doing it. Has anyone anything to add?
Yeah, just for the ground speed part, it's a lot more important than planning as well, as opposed to actually executing missions. Like you plan, for example, especially for strike missions, you plan on a certain ground speed because you want to make the time on target, where the margins are like 10 seconds or 5 seconds.
It's like what we fucked up yesterday. We got our timings wrong. if you look at the TAC view. And we almost forgot about our favourite one, but we've remembered it in the end. I think someone reminded us. It's Mach. Yet another mention. Yet another measurement of speed that we must know in our community and in real life. So, who wants to kick off with Mach and what it means and why we have it?
Very, very simply, it is how close to the speed of sound you are at any given area. Now, you might think, why? So, the problem is the speed of sound changes depending on what altitude you're at, because the different density of the air changes the speed of sound. So you can be doing Mach 1 at sea level, and if you do the same speed higher up, you'll be at Mach 1.5 or what have you. Because as density reduces, the speed of sound reduces.
Sorry, just let me interrupt a tiny bit there. Just a really analogy to really explain what he said there is if you were in your SL71 doing 300 knots indicated speed at sea level, you'll be doing like less than half a Mach, so 0.4 Mach or something. If you were doing that 300 knots indicated airspeed at 90,000 feet, you're going over Mach 3 times the speed of sound. Carry on, you guys.
Yeah, and the reason why we care about Mach number is because when you start approaching the speed of sound, where you go beyond it, the aerodynamics of the aircraft change quite considerably.
That is the main point of it at all.
Yeah.
Carry on, Cam.
I think the only reason that we need to discuss this is that certain planes will disintegrate if they reach the speed of air, because they're not, the speed of sound, because they're not made for it. So that's actually it. If you take an A-10 and dive it through the sound barrier, you will have no plane any longer.
Well,
there are the non-destructive things, such as in the Viggen, you'll Cap's noticed a few times if when you go near the speed of sound, it tends to dip down. And also in the transonic region, so just before you're about to hit the speed of sound, the drag on the aircraft is higher than if you go beyond the speed of sound.
Yeah, well, it depends on the plane, obviously, but...
Okay, well, I've learned something today. I didn't know that Mach, the ignoring the aircraft, I didn't know that the Mach speed, the speed of Mach 1, changed at different heights. So
because the speed of sound is way lower if you go higher up.
So I've learned today why that is important and why, therefore, it's shown on your aircraft, because it's shown on your aircraft, like the guys said, because it matters. If your plane's going transonic, i.e. just before Mach 1, you've got to know that, because your flight controls will change a little bit. And if you're on a...
It's also
if you take it to the extreme, if you're on a F-86 Sabre and you get to 0.95 Mach, I think it is, your controls get reversed. It's pretty major. And so it's important that it displays to you what your actual Mach is, bearing in mind that Mach changes at different altitudes. So that's why we see it and why it's so important. So I've learned that today. That's pretty cool.
Yeah, and if you go over Mach 1, you'll start breaking windows on people's houses.
We don't care about that.
And furthermore, I know that in civil aviation, when you passes, I think to remember, 18,000 feet, you change your measurement and the autopilot and everything to read in Mach, and you keep it at the Mach that the plane is designed for.
As you're approaching the transonic regime, you will experience a lot of drag. So basically, for aircraft like F-15 or basically air superiority fighters, you want to be above Mach when you fire your missiles, ideally, so that your missiles don't have to go through the transonic regime.
Either. That's interesting.
I don't know how well that's modeled in DCS.
Yeah. Well, no, because I've seen people, I always whinge at people when they're firing their F-15 missiles that they're going 450 knots and they're below Mach 1, and you can see the missile never really gets up to speed. But when you're really bombing it and you are, just punching through the sound barrier, kind of 700 knots, 1.1 Mach, something like that, depending on your speed, depending on your height, you can see the missile gets plunked way up to 2.5 kilonauts. So,
I mean, we call it the sound barrier. It is an actual barrier. I mean, it is a lot of drag you've got to overcome to get through it. But once you're through it, it's much easier.
So we hope that helps you explain it a bit, and why you can see me trying to figure out the TAC views that I do, trying to work out the different speeds. Any questions, and I'm sure there will be lots, or corrections or whatever, put them in the YouTube, and we'll try and go through them.